So we've mentioned file uploads. We talked about how to set these up on the front end very briefly with forms. Now we're going to talk about how to parse these file uploads, how to actually get our uploads saved to the server. So we're going to get this multipart request. It's going to contain text and an image. How are we going to parse through all of this information, all of these bytes, and get that image data saved to our server, saved on our hard drive? That's our goal today. So let's see what it's going to take to get there. So quick review. When we had forms and we want to, we have multiple ways to send the form data. We started with GET requests. Then we moved to POST requests with URL encoded data in the body. And then we moved to multipart form data. Multipart form data is the only one you're required to use. So it makes sense to only write code to parse multipart form data. You can parse the URL encoded stuff too. It's very similar to your query string. It's the same format as your query strings. So you might already have that code. But you have to do this multipart form data because it's the only one that will allow file uploads. So this is the one we want to focus on. This is the one I'll spend the most time on and really talk about how to parse this thing in the specific format. So this is what that format's going to look like. If we submit this form, this is our HTML. The browser is going to do all of the processing here based on this method and encoding type and take the name for each of these text inputs, take the content that the user submitted in those text boxes, and send them to your server in this specific format. So assume that I went to this web page and on the form I typed Jesse as my name for the commenter and good morning as the comment in that box, and then hit submit on the form. This is what the server is going to receive. Not exactly this because the boundary can be different. This will be different on each request, but this will be the structure and the format of that request that you receive on the server. Plus extra headers. I cut out all but the necessary headers here just so I can fit it on the slide. You're going to have, your browser's going to send all kinds of extra headers as you've seen as you're parsing these requests. So here's the format of those requests. It's going to be a post request at the form path, which we specified in our HTML, a post request to whatever path you put as the action. And this is going to determine, the multipart form data is going to determine the Mime type, multipart form data, which is going to give us a boundary. And then each input from that form, is going to have its own section, its own part in the body of this request. Each part is going to be separated by this boundary, preceded by 2 dashes. And that's the format. Last year I made the mistake of, I basically just left it at that and said, go figure it out. This year I'm going to go into a lot more depth on guiding you through how to parse these things. But first we got to talk about image uploads and talk about what we're actually going to be parsing. So to upload images, instead of text, you change that to file. You now support image uploads. That's it. That's literally it. Actually, I don't think maybe I will after again. I don't think I did it during lecture. I did it after lecture each time. But when you change this to file, you're going to get a button, which you've seen on many forms. Actually, I gotta pull one up, don't I? Where's my IntelliJ? I'll pull one up to make sure this is clear. So once you change this to file, you're going to get a file picker like you've seen on many sites. You've been to many sites wherever you have a file upload. There will be a button you press which pulls up your file system, your file structure for your device. And then you'll pick a file, and that file will be uploaded in that form. I won't run my server. I'll just open it as file. So here's a very simple form. This is the form from the slides. If I change this HTML, I'm just going to change this from text to file. That's all you have to do to get this file picker. I got a button. I can navigate all my files. I can choose which file I want to upload. And when I submit this form, that file is going to be attached to that form. I don't have a server running, so I don't get any response. But the request is going to contain that file when it's uploaded. That's all you have to do on the front end. You just change that from text to file. An input of type file. Your browser and your operating system are going to work together to let the user choose a file and upload that file and send that to the server. So on our front end, file uploads are no big deal at all. You change that type to file, and now you have an input on a form that accepts files and allows users to choose a file on their file system to upload to your server. So the front end's done. Front end's super easy for file uploads. The back end, on the other hand, is tougher. We do have to use multi-part form data for this. If you notice, it went by quick, but when I was in the browser, this actually didn't send the file. This only sent the file name. So all I got was the name of the file in the request, because this form, it was actually a GET request. This form, it has method GET. So it sent a GET request with a query string that contains the name of the file. That's not what we want. That's not what we want at all. We would get the same thing if we changed this to post with an encoding type of URL encoded. We would get the same thing. We would just get that query string would move to the body. Same thing, it would just be the file name. You only get the content of the file if your encoding type is multi-part form data. This is required. You have to use multi-part form data if you're going to upload files. So once you have encoding type multi-part form and a post request, you can't use multi-part form data with a GET request because you can't jam that in the query string. But once you have multi-part form data and a post request and an input of type file, now your file is actually being sent to the server, not just the file name. Everything will work if you don't do that. It'll just send the file name and everything will hum along fine. But when you try to parse the file name as the bytes of a file, guess what's not going to happen? You're not going to get a file. You're not going to get the content of that file. So we have to use multi-part form data. This is a requirement. If you want to support file uploads, that's the encoding type that you have to use. So we are stuck with this. There's no getting around it. We got to parse this stuff. So when we get this, we're going to get a request like this. I'm excluding the headers on this slide, where we change this to a file. So we're going to get a slightly different boundary here, a slightly different part. We're going to have more headers. We're going to have additional headers here. And then all the bytes of the file are going to go in the body of that part of the multi-part request. So now we actually get the bytes of the file, and we still get the file name. So if you want to use that file name, you still have that. But we do have the bytes of that file in the multi-part form request. But as we know from sending files, when in the images, we're working specifically with images because they fit this. Images are not UTF-8 encoded. They're not text encoded. They don't have any text encoding to them. The files that we're working with in the homework are JPG encoded. That is not UTF-8. So we cannot treat these as strings ever. So just like when you're sending images in homework 2, you have to make sure that the bytes of that image are never, ever, ever converted to a string, which is like 80% of the issues with homework 2, is at some point you accidentally converted that to a string, or intentionally and just didn't listen to me at all. At some point, if the bytes of that file are encoded as a string, you're going to get all kinds of decoding errors, because those bytes are not a proper UTF-8 format. UTF-8 has a strict structure. Either you have the first byte as a leading 0 and it's ASCII, or the first byte has a leading number of ones, and then a 0 with the number 1 specifying the number of bytes. And then each continuation byte has a 1-0 as its leading most significant bits. PNG is not going to follow that. It would be a pure, absolute stroke of ridiculous luck if your PNG image just happened to follow that protocol, happen to have all the most significant bits following that protocol. It's just not going to happen. If it ever happened, I would be surprised. It probably has never happened in an image ever. Probably never happened in any images where you're going to accidentally get something that's UTF-8 encoded. That's absolutely ridiculous. It's not going to happen. So as soon as you decode your image as UTF-8, everything breaks. And in some languages, your program just crashes. It says, decoding error. Sorry, I'm killing your server now. Same thing happens when we're reading images. When we're reading a request that contains an image, we cannot decode those bytes as UTF-8 or as ASCII or as using any other text encoding. Those are the two we talked about, though. You cannot decode them because it is not UTF-8 encoded. It's not UTF-8 encoded. So this still applies. And encodings, by the way, encodings don't go away. These are so important throughout, all of the internet, because of that fundamental fact that the internet can only send ones and zeros. That's all we can send. So we have to always talk about encodings, no matter what we're doing with the internet, because everything has to be encoded. And we have to send mixed content at this point. So we have one request with mixed content. And by the way, when you sent an image in homework 2, that was also mixed content. You were sending your headers as text, your image as bytes. So when the browser parses that, they have to be careful about how they parse it in the same way that we're about to do. The browsers have to do this. We're just on the other side of things now. The browser's sending us images, and when we're parsing, we have to be careful because we have a lot of text and we have bytes representing a file in the same request. So we have to piece this apart and be very careful about how we're parsing to make sure that image never is attempted to be decoded as a string. These bytes do not represent a string. They are not UTF-8 encoded. We just can't do that. Yeah, exactly. How do we know the pathing and routing if we don't convert the bytes to a string in the first place? That is a phenomenal question. And that's one of the big things we're leading to is how the hell do we do that? There's an answer. The foreshadow is byte parsing instead of string parsing. But let's lead up to that. Let's talk about the rest of this format. And we will get there, I promise. So, well, I shouldn't promise, right? What if my house starts on fire before we get there? I will attempt to get there. let's put it that way. All right, so let's tease this apart and look at all the pieces of information. The request line, this is the same format as before, except instead of only get request, we are starting to see post requests. So we'll see a post request for some path. So when you're parsing these, you have to make sure you're checking that. I mean, I'm sure you're already checking these, but you have to check the request type and the path to make sure that you know what you're handling before you start parsing. So if you get any request ever, and you're parsing every request as though it's a form submission, you're going to break all of your GET requests. You're going to break your get/hi, get/hello, get/ for the root HTML. You're going to break all that stuff if you treat everything like a form boundary. So you do have to do parsing after you read the request type. So, but you have to read this before you know that information. So you have to be careful about the order you're reading things. Let me just click through and it'll make sense later. I'll show you. The content length. So this is where we have to start reading the content length. Before you were writing it and making sure the content length matched the number of bytes that you're sending in the body. Now you're on the other side of that. You have to read the content length and the content type. Content length, content type, you're going to be reading those instead of writing those. Content length, the number of bytes that appear after this blank line. You have to read that and then read that many bytes from the body. This is important because you will not always, you might think, well, I don't feel like doing that. I'm just going to read all the information from the TCP socket, and however many bytes I read from the TCP socket, that must include the content length. Like I got the content length. The problem is you're not always going to get the entire request on one call to receive from the TCP socket. you might call receive on the TCP socket and have a partial request. One thing you can assume, and I'll repeat this a lot, one thing you can assume is that on one read from the TCP socket that you do get all of the HTTP headers. So on one read, you at least get to the blank line here. You get the entire head of the HTTP request. You can assume that because without that, the first read might not contain the content length, and then now you're in trouble. And that's why there are limits on the size of the headers that we talked about earlier. There are limits on the size of the headers of an HTTP request to make sure that you can read all of that in one read. So we can always assume that, at the very least in this course, you can always assume that. So you can parse the headers right away, get the content length, and then start reading more information. If you didn't read all that content length from the body, you have to call receive again. You have to get more data from the socket until you read content length number of bytes. We'll get into this much more in depth on Monday, but some of you, if you've started Objective 3 already, when you get a file upload, even if the file is smaller than the size of your buffer, a lot of browsers will send the headers and the body in two separate chunks of data. So when you call receive once, only the headers might be there, even if you have a very small file. So this is something you should be aware of, even without arbitrarily large files. But if you have a file that's much larger than the size of your buffer, that's going to be sent in chunks as well, or at least read in chunks based on your buffer size, and we have to be aware of that. But most of that content, that's Monday's lecture, that's Monday's job, and we'll talk about that in depth on Monday. Can a single receive have the end of one request and the header of another? Yes and no. Yes, but we're not going to deal with that. So for our purposes, the browser is going to create a new TCP connection for each request. And that connection is closed at the end of that request. We can do what you're saying, but we would have to respond. And you can see this in pretty much any website out there. They're going to respond to an HTTP request with a keep alive header. And that says, hey, instead of creating a new TCP connection, let's just keep this one open and then send all the requests back to back on this TCP socket, and I'll handle that on my end. I'll know what you're doing. We're not sending the keep alive header, so the browser is going to close that TCP connection, create a new TCP connection, go through the three-way handshake again, and then make another request. So we actually avoid that just by being a little inefficient in what we're doing, just because, you got enough to do in this course. Maybe someday I'll add that, but you don't have to worry about it. And you can assume the chunks are in sequential order. That's what TCP takes care of. Sent requests. If client 1, If client 1 and client 2 sent requests at the same time, yeah, they can actually be mixed. We won't have to worry about that just because the TAs and I were not going to test that and try to have two clients sending simultaneously. When we get to Websockets, though, that will be important, and we will handle that in homework 4. That will be a thing. For that, each TCP library has a way for you to read an ID for that specific client, and then you can sort all of their requests by ID. You can sift through them and say, this is for client 1, this is for client 2, and then store the bytes that you're reading in two separate, probably the same data structure, but as two separate values on your server. That won't become important until Websockets, but yeah, technically for homework 3, if you had two clients uploading large images at the same time, those are going to be mixed together. Yeah, Websockets is a bit of overhead. I won't get too ahead. I'll keep this brief. But what WebSockets do is keeps that TCP connection alive and then sends WebSocket messages over that TCP connection. So you have long-term connections when we get to WebSockets. So you have to keep track of which socket belongs to which client. So when you want to send information to a specific client, you know which TCP connection, which socket to send that information to. So you have the overhead of keeping references to each socket that you've left open and then sending information over that socket. Instead of right now you receive, you have a reference to that socket when you receive the data, and you just send to that socket, and then you forget about it after that. With WebSockets, we got to care about all those references to the sockets. And it is a bit of overhead. Okay, so we read the... Oops, I'm on the wrong thing. So we read the... I move it around a bit. I'm a little antsy this morning. But we read the content length, read that many bytes. We'll talk about that more in depth on Monday. Next, the content type. The content type is going to be multi-part form data as the Mime type. And we're going to have an extra value here. This boundary equals, and then whatever the boundary is. I haven't seen this, but according to the documentation, this can be in quotes. So something to keep in mind if you do run into that. If your browser happens to add quotes, make sure you're removing the quotes from the boundary. This is using the same format as when we specified UTF-8. When you sent that UTF-8 file, you had the content type text/plain semicolon encoding equals UTF-8. Was it encoding? I don't remember the exact key, but we did the same thing. We used the same format. Again, you're on the other side of this. Instead of writing this format, you have to parse this format. So in your content type, you're looking for the semicolon, splitting this on the equal sign, getting whatever's after the equal sign, and in some cases, if your browser's adding the quotes, removing quotes. A quick replace quote with empty string can get that for you, which you do have to do down here, actually. Now you have a boundary, and you can start parsing the information down here based on that boundary. So read content length number of bytes. That's the entire body of your request. And now we can start parsing this body. Now remember, this has to stay as bytes. You can't convert this to a string. And let me just double check. Yeah, I do it later. So all the string parsing, I'll talk about how to do that. I do have slides on it. I probably should have put it earlier. But anyway, read this many bytes. We'll just go a little quicker and get to it. Now you can separate the parts of the request based on that boundary. So this boundary is going to separate each part. And I have two parts to this form. I had two inputs on the form. So I have two parts that need to be extracted and parsed separately. So this has two parts. I'm going to look for that boundary, find the parts, and then parse them independently of each other. The boundary is going to determine where the cutoffs are between the parts of the request, and this is going to have a leading dash dash. So the boundary isn't the strict boundary. The full boundary separating the data is going to be two leading dashes and then the boundary. So this has 4 dashes here. There's going to be 6 dashes here when it's used as the actual boundary of data. It will be dash dash then the boundary. So when you read this boundary, add your dash dash in front of it and then split your parts based on that boundary with the leading dash dash. To mark the end of the parts, we're going to have a boundary with a leading dash dash, just the full boundary as before, but also with a trailing dash dash to specify that this is the last part of the multi-part form. The protocol, most sites don't use this, but the protocol says that you can have information after the last part. You can have a footer. You can also have a header before. So that's why this trailing dash dash is there for what it's worth, to specify that, hey, this is the last part. You might say, well, I'm at byte 9937, so of course it's the last part. But there can be a footer, technically, according to the protocol. Even the protocol says, nobody actually uses this, but technically you can. I think it's for backward compatibility for an older form of sending multiple information before multi-part form data. So the last one is going to have the trailing dash dash. So the thing to be careful about, okay, take your boundary, append the leading dash dash, split your content on that. Make sure, and then you're going to have this chunk, this part in an array, you're also going to have a dash dash in that array if you're just splitting based on the boundary with the leading dash dash. When you have this trailing dash dash, just make sure that you're not trying to parse that with headers and with a new line, a blank line and all that, because your program's going to crash, your server's going to crash. Be aware that you're going to have that trailing dash dash if you do, body dot split, or, well, you got to do it in bytes, but if you're splitting this body based on this boundary, you will have the last element of your array as dash dash. So be aware of that. At least one of you is going to ask me that in office hours and be wondering why your stuff's crashing. Each part of the request, of the body of this request, is going to follow the same format mostly the same format as an HTTP request or an HTTP response. We're going to have any number of headers, a blank line, and then the content. One thing to be aware of, technically, your content can include a blank line, so make sure that you're only reading one blank line here. So to parse this, you're going to parse all the headers same way you did for an HTTP request, which again, having a general header parser, having that code, that function is going to benefit you greatly. So run that same code on all these lines, everything before the blank line, before this CRLF. Parse all those, get the information you want, which is going to include the this content disposition. This is going to tell us that it's form data. This is always going to be form data in our case, and also the name of the field for this part of the request. So you have to parse this, get the name, again, same format up here, semicolon separated pieces of information, get the name, remove the quotes, split on equal, remove the quotes, however you want to parse this, and get the name. So this is the commenter input from that form. This is the upload input from that form, and the file is also going to have the file name that the user uploaded. So whatever file name this had on the user's system. So parsing these headers, getting any useful information that you need out of the headers, out of this content disposition, and remembering that information, doing what you need to do with that information. The content type is optional for the parts of a multi-part form. If it's provided, obviously that's the content type of that content. So this is an image, a PNG image, and then all the bytes will be here that we can read. If the content type is excluded, it defaults to text plain. So there's no content type here, so this is plain text, a plain text formatted body of that part. The content length is not included in the parts. The whole point of content length, which I don't remember if I motivated this or not, why we have a content length. It's implicit when we talk on Monday about buffers. But content length, the whole purpose here is to make sure that you read the entire body of the request before parsing the body and before handling that request. So content length, here's how much information I'm sending in the body, and then make sure you read that much information before handling this request. That same doesn't apply to the parts, because by the time you're parsing one of these parts, you already know that you've read the full request. So we don't have a need for content length here. You just read content until you find the boundary again. Once you find the boundary, that's the end of that content. So we don't need content length, so we don't use content length. Why do something that we don't need to do? So no content length in the parts. Just read everything after the blank line until the next boundary. I forgot to mention, the boundary is guaranteed to not be part of the content of this. Last time I mentioned it, I was a little iffy on it. I checked the documentation in the protocol. The boundary will not be contained in any of the data, any of the actual data that we want. So you can safely split the content on this string. You know that that's not going to interfere with your parsing. It's the browser's responsibility to come up with a string that is not contained in any of the data. If you do get a boundary that is contained in the data, you got a broken browser. Like you got to update your browser or open a ticket with the browser and say, hey, what the hell? What's going on here? This boundary won't be contained in your actual data. It can safely be used as a boundary and will be generated by the browser to ensure that that's the case. Okay, and now we finally get to the juicy part. The bytes of the file. This is not a string. You can't decode it as a string. You can't encode it as a string. It's not a string. So if you get your entire request and you say .decode, because I got to parse this string and the headers and everything, things break. You just corrupted your file. That's no longer an image because you're going to have all kinds of decoding errors and everything's broken. You also can't try to encode this as a string because those bytes, it's just not a string. It's not a string. Will there be a CRLF part before the next boundary? I believe so. Will it? That's a good question. I'm blanking on that one. Will there be a CLRF before the boundary? I want to say no, because I don't think so. But whenever I print one of these out, that's always on a new line. So is that just happening by chance? That can't be happening by chance. There must be, but I'll have to look into that one. There must be, because how would this print? Like, that file would have to end in a new line to be able to get that. And every time I print them out, that's what it does. Is there a class that teaches more about encoding? I'm not sure if we have one at UB. If you want to know about like image encodings and video encodings, we do have one for that. I forget exactly what it's called, multimedia content, something like that. We do have a course in that, which will talk about how MP3s compress audio files and things like that. If you want to learn about that stuff. Encodings like text encodings, I'm not sure. I think this might be the course that goes most in depth, but I'm not familiar with every course, so I don't know. There might be another one that goes into it. So how do we do this? How do we avoid parsing this as a string? How do we avoid converting this to a string? There's a string right after it. There's strings right before it. We have to parse those. So how do we parse those while avoiding parsing this as a string? So the answer is going to be byte parsing. We're moving away from string parsing now and starting to parse bytes. We're going to parse this as bytes without converting this entire thing to a string ever. So you're never going to say, I got a request over my TCP socket. I'm going to convert this whole thing to a string. Oh, wrong. You're wrong because that contains an image and you just corrupted your image. So we have to never convert the entire request into a string. We can extract parts of it, parts that we know are strings, and then convert those to strings, but we can't convert the entire thing to a string. So how do we do that? We're going to work in just the byte array. We're going to look for subsequences of bytes in the array, and then we're going to create subarrays based on the boundaries that we've found. So what does that mean? Let's parse the header first. So you're going to get this whole request, or at least just the headers. And you need to parse these headers without touching the body yet, because you have no idea what encodings are being used in this body of the request until you read at least the first two pieces of information. This is a GET request for /hello. All right, I can safely parse everything and handle it all as strings. This is a post to /form path. Oh crap. This should contain a file, the bytes of an image. I can't do that. So to get to that point, to be able to read the headers, you have to get the headers first. For that, we're going to look for the /r/n/r/n to be able to separate the body from the headers. And anything before that /r/n, we're going to create a subarray of that data, convert that to a string, and then do our header parsing like we've done with GET requests. So to find this /r/n/r/n, we're going to take this string, convert it to bytes, so encode it into UTF-8. Once we have this as a byte array, a UTF-8 encoded byte array, Now we can look at our request as bytes, the byte array of our request, and look for that subsequence of bytes. Now, however you want to do that, however it works best in your language, that's up to you, but you need to find that subsequence of bytes. So you have an array of bytes, you have a subarray of 4 bytes, and you want to find the first, specifically the first instance of that subarray of bytes in the request, in the bytes of the request. Once you find the index of this as bytes, once you find the index of that, which in this case will be right here, once you find that index, now you take your byte array and you say, okay, give me the subarray from index 0 to that index. Now you have a byte array that's just your headers, just your request line and your headers. Now you decode that as UTF-8 because you're guaranteed that the headers will be ASCII only characters. You just use UTF-8, it contains ASCII. Decode this as text. And now you can parse like you were doing in the first 2 homeworks. You can parse using text parsing. Call whatever function. Hopefully you wrote a function to do it in homeworks 1 and 2. Call that function, parse the headers, and get all the information that you want. Extract that information out of them. Get the type, the path, all the headers. And you didn't have to parse headers before in homeworks 1 and 2, so write some code to parse headers if you haven't. Iterate through all these lines and extract the keys, the name for each header, and the value for each header. And then for each header that has multiple parts, you can look for these semicolons and piece that apart. Look for equal signs, piece that apart. If you write a general header parser function, it's going to pay off in the long run. So parse all these headers as text. Now you know, okay, this is a post request to form path, so I'm and it's multipart form data. I read all the body, but the body is going to contain an image, so I have to be careful about how I parse the body as well. So how are we going to do that? Similar idea. We're going to read everything. We're going to read everything after that CRLF. That's the body of our request, which you already have in some data structure somewhere because you were checking the content length and making sure you read that many bytes. So you by this point, by the time you're parsing the body, you've already read the content length number of bytes. So you have all this in a byte array. And now we need to separate the parts of that. We'll do something very similar. We'll take this boundary, which we have as a string, because we already parsed the headers as a string. We separated it from the rest of the request. Parse this as a string, and we have the boundary as a string after you parse all your headers. We have the boundary as a string. Prepend the 2 dashes to it to get the full boundary. Convert that to a byte array. So encode this, and then look for that sequence of bytes in the body. And each time you find that subsequence of bytes, separate out the subarray containing that part. So look for this. You found it here. You found it here. So from this index to this index, you can create a subarray of that and put that aside and say, this is one of my parts. You found the boundary again here. You can go from this index to this index, get all this information, set that aside and say, this is another one of my parts. And then you find a dash dash, and you say, okay, that's the end. But you're doing that in bytes, not in strings. Byte parsing, not string parsing. So you convert this to bytes with the leading dash dash. Look for that sequence of bytes, and each time you find it, you can separate out a new part. So now you have each part as a separate array. This one is all text. You got to read the headers. You got to go through the same thing to find out, but you can read this in all text. But the file, how do we do this? Well, same thing that we did for the overall request. We're going to encode /r/n/r/n. Find that right here. We get the index of that. Get a subarray containing all the headers. Parse the headers as UTF-8 because we are guaranteed that they will be ASCII only characters. so we can safely parse the headers as a string, which is why the protocol says that, so we can write parsers, or else no one would be able to write parsers. We're going to parse that as strings, get all the information that we want. We're going to realize, hey, this is an image. This is where my image went from that form. There's a file name, discord.png, which you can or can't use. It's up to you, which we have a few slides on that. But the name, upload, the content type, whatever you want to piece out of here to figure out that this is the image. This is the part containing the image. Now you know everything after that subsequence of bytes in this subarray. Remember, we already got rid of this. So everything after this is going to be the image itself, the bytes of the image. Get those bytes in a subarray. And now you've successfully extracted that file, all the bytes of that file, without ever converting that file to a string. You have the bytes of the file in some byte array. Now, oops, I got ahead of my slides. Now we have the bytes of our file in a byte array. And now we can do all our file stuff with it, which for our cases, save it to our hard drive. So save that file to our hard drive, give it a file name, save it, write those bytes to a file. And now we have file uploads. Now you can serve that file just like we did in homework 2. You can serve that file to other users, and you successfully have a file sharing website that you built from a TCP socket. This is where you're going to be after homework 3. You now support file sharing in your TCP-based HTTP server. It's a big accomplishment. When you get done with homework 3, you should feel amazing about that. That is a pretty big accomplishment to get a file sharing, an image upload site, an image sharing site, starting with a TCP socket by parsing HTTP headers and speaking HTTP. It's pretty freaking cool. I think so anyway, but of course I'm biased, but I think it's pretty damn cool. So there's one last thing I want to talk about. So when you're taking these file uploads, it's up to you what to name the files. I said you may or may not want to read the file name that you have uploaded. You might want to create a naming convention for your files, and you really should create a naming convention for your files, which can be as simple as, this is the first image that has been uploaded to my site. I'm going to name it image1.jpg. It can be as simple as that. But you should have some naming convention. The problem we're solving there is, what if two users upload files with the same file name? If you're using their file names, what do you do? How do you resolve that conflict? If you have your naming convention of image1, image2, or what modern sites do is create some semi-random strings to represent. Like you upload a YouTube video, you're going to get an 11-character ID that looks pretty random to us. Name a UUID. Yeah, you could. I'm thinking GUID. A unique ID. You have to give each image a unique ID. Pockets, you're absolutely right. So each image has to be some unique ID. Most sites will give these somewhat random things. That's partly so people can't, I uploaded an image and it was called image 3002. Let me just change the URL to image 3003, and now I can look at somebody else's image. You can start figuring out the order in which people upload. You just don't want to leak information like that. So they'll give somewhat random. They're not actually random, but they'll look random to us. GUIDs work as well, but they're such long strings. They're just pretty cumbersome for this use, for this case. But you want some naming convention anyway. When you were hosting these, and depending on how you did homework 2, you could have this problem in homework 2, but certainly you'll have it in homework 3. When you're hosting these images, you're going to have some path. The path for homework 3 is up to you, how you want to design it. You can just stick with image/ like we did in homework 2, or you can use a query string like this, or you can change the path name to uploaded images, whatever you want to do. It's up to you. It's up to you how to design that part. But you'll have some path. No matter what you do, you'll have some path that takes an image name, a file name. What you're going to do is parse this request, figure out which image is being requested by that file name, go to your hard drive, open up that file with that name, read the bytes of it, and send the bytes of that to the user. Right? That's what you have to build for Objective 4, is some way for the user to say, give me this file, and you'll be like, let me read that file and give it to you. Like, you have to do that. In one way or another. It might look, depending on how it looks, you might build it one way or another. But that's the functionality you have to have. User says, I want this file. You send them that file. And a clever user sends this request. They just stole your private encryption key. This is standard. This is where your encryption key is going to be stored in a Linux system. Is this file, this IDRSA, in your home directory, in your hidden SSH directory. That's where your private encryption key is going to be stored. So a clever user says, well, /image gives me whatever file name I asked for. Instead of flamingo.jpg, I'm going to say your home directory, your SSH keys, and your private SSH key. I want you to send that to me. And if your server isn't carefully coded, it's just going to take this substring, read that file, and send it to the user. You can't allow this. You can't let them do that. You can't let them access arbitrary files on your system. So in Objective 4, there's a security warning in the testing procedures. You can't allow users to request arbitrary files on your system. So if you're letting them request this and giving up your private encryption keys or giving up the code to your server, if they do /server.py, you can't be sending them those files. You can't let them access anything but the image files. So I'll let you be creative on how you approach this, but I'll give you two options. If you use either of these two options, you're going to be good for grading purposes. This is a bit of a rabbit hole. It's tough to protect against this 100%. But if you remove all dots, all dashes, and all tildes, that'll be enough for at least for grading, and that's going to limit pretty much every attack except for sophisticated attackers who are going to start, maybe they'll escape these characters, maybe they'll percent encode them, and if you're decoding, percent encoding, there are other ways they can do it. But getting rid of those three characters, that's good first line of defense. If you really want to protect against this, the strongest defense you can do is maintain a list of all the valid files that a user can request, and then if they request something that's not on that list, send them some 400 level, a 404 or a 403, a 402, something that says, hey, you requested something, but we're not giving you that. We're not giving it to you. So you do have to protect against this in your homework 3. And just a quick reminder, don't forget about your Mime type sniffing. Actually, I forgot to add this to the doc, so I won't add it after the fact. But you should have your Mime type sniffing. It's more important now than ever, because now is when your attackers can, instead of an image, upload a JavaScript file, and you're going to send that JavaScript file to all your users. You want to make sure that the browser isn't sniffing that as a JavaScript file, even though you have a Mime type of image/JPG. You don't want the browser saying, oh, you said it's an image, but this sure looks like JavaScript to me, so I'm going to run it. You don't want the browser doing that. So you got to disable sniffing. You have to have that no sniff header to be able to disable that. I should have, there was an oversight. I should have had that on the document. But I won't change it after the fact, after people started the assignment. But that is ever increasingly more important now that we're actually handling user data. It's very important.